Okay, guys, this assignment is another one of those demo assignments. There's probably going to be, I don't know, 6 of these maybe. Maybe more, 7, I don't know. But what I try to do is especially for the more challenging assignments, I try to put up this demo. It does serve as a quiz, just as I showed you before. Let me go and show you what's going to happen here, just so everybody understands. The assignments are worth 100 points. The demos are worth 25. So just by following along on the video and working the problems, you submit this, you get a pretty easy 25 points, which so far is each one of these is about 1.5% of your final score. Now that weighting really shifts a lot once we put the exam scores in. But nevertheless, let's go to the main menu, and I'm going to run through this the way you guys would see it. So I'm going to go to assignment, and I'm going to do demo the normal model. So there's 8 questions. So let's get busy. So question number 1 deals with the empirical rule, and remember it's also known as the 95 or 68, 95, 99.7% rule. They call it almost all, which is cool. So roughly what percentage of scores are between z-scores are between -2 and +2? So that's really easy. Gosh, don't you wish statistics stayed that easy? Roughly what percentage of z-scores are between -3 and +3? Well, almost all. Not really sure why I included this problem. Between -1 and +1 would be 68. And more than 0, guys, remember 0 cuts the symmetric distribution in half, so 50% above and 50% below. Between 1 and 2, well, we did that earlier, right? So we know that there's 95 from here to here and 68 from there to there. So if I take 95 minus 68, and then just divide that by 2, I get, what, 13.5%? Okay, question number 2, right? Yeah. IQ scores have a population mean of 100, standard deviation 15. They're approximately normally distributed. Use one of the StatCrunch outputs to find the probability that a randomly selected person will have an IQ of 75 or higher. So guys, we know that has to go to the right. State whether figure A or figure B is the correct representation. Well, guys, clearly it must be B, because shading to the left says it would be less than. Shading to the right is above, so use figure B to find the probability. Okay, interesting. The probability that a randomly selected person will have an IQ of 175 or higher. All right, let's see, how do we get to StatCrunch from here? I don't know. Let's see. There should be a StatCrunch. Here we go. Go to StatCrunch. All right. So what we need, IQ of 75 or above. So we'll go to Stat. We'll go to Calculator. Normal. So we have a mean of 100. Standard deviation 15. Above 75. Compute. So let's go back and see how many places we're supposed to round to. 4 places, right? So it looks like to me it'd be 0.9522. All right, next question, number 3. Use a table to find. Well, guys, we don't use tables. Okay, tables aren't cool. To me, using a table is kind of like taking a horse and buggy. If we wanted to go to Columbus tonight for dinner, it'd be like taking a horse and buggy to dinner in Columbus. We're not going to do that. We're going to jump in our car and listen to our iPad and put the top back and be all cool, right? So we're going to use the equivalent of coolness called stack crunch. So find the probability that a z-score will be minus 1.75 or less. Guys, that's really easy. We do the standard. Since it's a z-score, we have a mean 0, standard deviation 1. We need less than negative 0.75. So 0.2266. Now, which one matches up? Guys, clearly looking at the picture, it will be C. And the probability was 0.2266. Okay, well, why isn't it? Okay, oh, shoot, 1.75. Guys, first mistake I've ever made. You guys are probably screaming at me saying no. So let's try 0.0401. And I bet that one's right. All right, cool. Which graph below is the area to the right of negative 1.75? Well, guys, that's obviously going to be up here. If we look at this, it's going to be to the right of that, so clearly it has to be B. And it says find the area to the right. Well, all we need to do is take 1 minus, I'm just going to type it in, 1 minus 0.0401. I don't know if it'll take that or not. Let's see if it, okay, yeah, it's not going to let you get away with it that easy. So let's just type in the, so what would it be, 0.9599? Okay. Now, if that kind of thing doesn't turn you on, you just don't like that, then go over here. Do greater than, and you get 0.9599. All right, continue. Which graph shows the standard normal between 0.9 and 1.8? So we know it's going to be, let's see, no, it's going to be B. That one's kind of tricky there because it shows you 1.8, but it keeps going on all the way out to positive infinity. So they're trying to trick you a little bit there. But we're not going to be tricked, are we? Find the probability the Z will be between 0.9 and 1.8. So, guys, that's one of those between problems. And what, 0.9 and 1.8? Compute. So 0.1481. 1481. All right, moving right along. Question number 4. The distribution of white blood cell has a mean of 7,500. Guys, I'm going to write this down over here on a sheet of paper. And a standard deviation of 1875. So for all you nursing students out there, I know you woke up this morning dying to know that. You probably maybe already knew it. So what is the probability that a randomly selected person will have a white blood cell count between 5,900 and 10,000? So which one of those would represent that? Now, what they do, they're kind of tricky here in that they give you the illustration as a z-score. Now, let me exit the screen here and bring this up. So a little bit tricky, all right, but it's not tricky enough to get us. So what we need is we need the z-score for 5,900. So the z-score there is negative 0.85. And then we want to do the z-score for the other end, which is 10,000. Trying to get this where you guys can see it the best. And that's 1.33. Now when we go over to our chart over here, 1.33, negative 0.85, we need the area between, so we know it has to be one of these two. It has to be A or D. And this A can't be it. Let me make this part larger. A can't be it because that's less than 1, so we need to do this. Now find the probability that the randomly selected. Now guys, this is a kind of an interesting place in that we can use either the z-score or we can use the raw score. And I want to demonstrate this as a teaching moment. So I want the between. So if I use the white cell count, isn't that what it was? Then the mean would be 7,500 and the standard deviation is 1875. So if I put in the cell counts, 7,500 and 10,000 and compute, I get an answer of 0.4088. So remember that, 0.4088. But since I found the z-scores for each of these, I could also go mean 0, standard deviation 1, and put in the negative 0.85 and put in the z-score for 1,000, which is 1.33. And you'll see that I get something completely different. Why? What did I do here? That makes no sense. I must have made a typo. 7,500 is the mean. 1875 is the standard deviation. So we had 5,900. And we had 10,000. Okay, well, I don't know. I'd have to go back and watch the video. So the answer should be 0.7121. So I must have done a typo. You guys are probably screaming at me. Guys, either way, we get the same answer. And we need to put that in. I'll be interested to go back and watch that and see what I did, because it had to be a typo. Okay, between 5,900 and 10,000. And the mean is 7,500. 1875. Okay, what is the probability that a randomly selected person will have a white blood cell count? Am I absolutely losing my mind here? 5,900 in 10,000, all 3 places. Oh wow. Look at this thing being kind of picky. All right. Interesting. All right. What is the probability that a randomly selected person will have a blood count between 5,000 and 11,900? Well, guys, again, we know it has to be one of these that encompasses an area between 2 parts, 2 pieces. So what we would need to do is calculate the z-score again. So I'm going to do it for the 5,000. I'm not going to show me entering this in the calculator, but because you guys can just follow before. But it's negative 1.33. So when I look at the left bounds, negative 1.33 has to be this one. Find the probability. So 5,000 and 11,900. So 0.899. Is it 3 places? We don't want to get our hand slapped again, right? All right, what was the probability white cell count of more than 10,500? Well, guys, there's only one that could work here. 10,500 is above the mean of 7,500. So my line has to start to the right of 0, and it has to go to the right because we're looking right here of more than. So guys, D is the only one that could be possible. And so 10,500. So greater than 10,500. So 0.055. I can't wait to go back and watch the video and see where I screwed up on that one problem. I'll be very interested to see. Okay, in a standard normal distribution, if the area to the left of a z-score is about 0.6182, what is the approximate z-score? Now, guys, this is a place where I think it's kind of cool to look at a picture. So first of all, we're talking about z-scores. So z-scores mean 0, standard deviation 1. And we want area to the left, so that means over here. So remember, this would be 0.5, so we want 0.6. So it's going to be somewhere right in there. So we want the area to the left to be 0.6182. Okay? So we know the z-score is going to be positive something. So let's go do it. So I would want standard. I want a mean of 0, standard deviation of 1. I want the area to the left, and I want the area to be 0.6182. So 0.3008. So let's see how they want us to put it in. 2 places, 0.30. Number 2, we want z-score that gives a left area of 0.98. Okay, so a left area of 0.98 is going to be pretty much exactly what we just did. So 2.05, 2.054, 2.05. I'm really glad. I can't. Oh, what we got? Round to two places. So we want z-score that gives a left area of 0.98. So why am I wrong? 0.98 left area, 2.05. What's going on here, guys? Two places as needed. Huh. Okay, mean 0, standard deviation 1, area to the left 0.98. Find the z-score that gives a left area 0.98. All right, okay, I see what's going on. 0.55. Okay, I thought I was on the same problem, but apparently we've gone on to another problem similar to that, and I'm working. Okay, all right, I see what's going on. So we need 0.55. So the answer to the first one would be 0.13, because I got kind of sloppy there, because those two problems were very, very, very similar. And now we're going to work B. Choose the correct answer below. So we want 0.55 area to the left. So we got to have shaded to the left. And so guys, it has to be B. The only two that could be right is either B or C. And you can see that this line right here is to the left of 0. So this area would be less than 0.5. So the only possible answer would be B. Second, now I get to work number 2, 0.98. So the Z is, we've already done this, 2.05. I have to pay more attention when I go on to new problems and not try to work old problems. So 2.05 to the left would clearly be B. All right, next question. 7 of 8. Cool. College women have heights. Normal distributions, mean is 60 inches. Standard deviation is 2.7. Find the height at the 75th percentile. So guys, what we're talking about the 75th percentile is you're just finding some height here for women that has 75% of the distribution below it with a mean of 60 and a standard deviation of 2.7. So that's going to be a very easy one to do. So mean is 60. Standard deviation is 2.7. We want less than, but we want our area to be 0.75. So essentially what we're finding here is Q3. So 61.82. Okay, just one place. I don't know why they're, whatever. All right, find the height at the 25th percentile. Okay, well, it's going to be pretty easy, isn't it? Uh, 58.2. Find the interquartile range. Well, guys, it's just the difference. So it looks like to me that's going to be 3.6. Is the interquartile range larger or smaller than the standard deviation? Well, guys, the standard deviation is 2.7. This is clearly larger. And on to the final question. All right. According to the data for population, 3-year-old boys have a mean height of 38 inches and standard deviation 2 inches. We can assume normality. Complete parts A and B. Find the percentile measure for a height of 36. So I want to write this stuff down. So we have a mean of 38 inches and a standard deviation of 2. So we have a height of 36, and we want the percentile. So guys, remember, we have the mean of 38, and percentile just means what percentage of scores is below. So, pretty easy problem, right? So guys, this is going to be at the 16th percentile. So it says to the nearest percentile, so that'll be the 16th. If this 3-year-old boy grows to be a man with a height of the same percentile, what will his height be? Use a population mean of 70 and a standard deviation of 3. All right, this is an interesting problem. So we have a new distribution with a mean of 70 inches and a standard deviation equal to 3. And essentially we want to know what score, if we change that to a 70 and have a standard deviation of 3, what score corresponds to the height as 3 years old at the 16th percentile. Okay, so again, pretty easy stuff. So we want a mean of 70, standard deviation of 3. We want the area to the left to be 0.16. So 67 inches would be what the person would grow to be. All right, guys, that's it. Again, this is a, once we're done, we'll come in and save this, and you'll get pretty easy quiz score. All right? So, guys, that's all I got. Hope this helps. Take care.